This is lesson 7.1, so we've gone from 5 point something, which is in chapter 5. We've hopped all the way over chapter 6, which is going to be the next unit. And then we're into chapter 7 now, which is still part of this unit. We're going to be determining absolute values of things and understanding what an absolute value is by relating absolute value to a distance. To begin with, the absolute value of a number is how far the number is from 0 on a number line. Distance is how far. Now, I'm just curious, is anybody taking Physics 20 right now? Maybe not, because I think Physics 20 might be offered right now in this period. But some of you took Physics 20 last semester with me. And we made a big deal about talking about distance versus displacement and how distance direction is unimportant and displacement direction is important. Well, the same thing is true here. Distance doesn't care about direction. If I say to you how far it is from Millet to Wetaskiwin, and you say 13 kilometers, which I think is pretty close, it doesn't tell me whether you're going from Wetaskiwin to Millet or Millet to Wetaskiwin. It's telling you the distance between those 2 points. So what does this mean? Well, first of all, we need to introduce the notation. It's like a set of brackets. The absolute value of x is written as x inside of 2 vertical lines. So from now on, when you see that, and I think in Physics 30 we used it when we talked about percentage error possibly. I'm not sure if I did that or not. But what it means is, how far is that number from 0 on the number line? Well, what is the absolute value of negative 12, and illustrate it with a number line? Listen, you're not going to do this with a number line each time. We're in a learning mode right now. If I look at a number line and I indicate where 0 is on the number line, and I indicate where negative 12 is on the number line, the absolute value of negative 12 is how far it is between those 2 points. So this distance from here to here is the absolute value. I'm going to just move this so I have a bit more room. Is the absolute value of negative 12. That's what it means. It's not a difficult concept. The answer is the absolute value of negative 12 is 12. Negative 12 is 12 away from 0 on the number line. So the absolute value of negative 12 is 12. Well, big deal. You know what that's telling you? The absolute value of a negative number is the value of the number without the negative. But it's going to become more complicated than that later. Okay? So this distance is 12. It's almost so simple to be confusing, right? Almost like, should it be harder than it is? No. Well, what about the absolute value of 5? Well, we can draw a number line. I would hope everybody understands that this is going to be equal to 5, because if I look at where 5 is on a number line and I look at where 0 is on a number line, by definition the absolute value of 5 is how far away from each other those 2 points are. It's 5. And I want to introduce something here which is going to amp this up to a higher level, which will be important for later, starting tomorrow. What we have basically learned from example 1, A and B, is that the absolute value of a number is the number if the number was greater than 0. I want you to roll that around in your head. The absolute value of a number is just that number if the number is a positive value. Another way of saying this is, if this number inside is positive, you don't need the absolute value symbols. Right? This is saying the absolute value of 10 is 10 because this number is greater than 0. It's going to get very difficult starting tomorrow, and I think this will help you. Once again, if the thing you're taking the absolute value of is already positive, then you just don't need the absolute value signs. But what if, and this is really going to, it's not going to hurt your brain, that's what I was going to say initially, but it's going to require you to think more. What if the number you're taking the absolute value of is negative? What is the absolute value of x going to be equal to if x is a negative number? Want to take a stab? Negative x. Negative 1 times x. Now, would you agree in the limited time we've talked today about absolute value that absolute values are always positive? So some of you might look at this and go, well, how can the absolute value be negative? It's not. Because x is negative. This is saying if the thing you're taking the absolute value of is negative, then multiply that thing by negative 1 to make it positive. Right? So, for example, the absolute value of negative 4 is equal to negative 1 times negative 4, which will make it positive. And the reason for that is that thing is already negative. So to make it positive, you multiply it by a negative. So that's a little bit more of a sophisticated way of looking at it. Listen, I know you don't need to do that to know that the absolute value of 5 is 5 and the absolute value of negative 12 is 12. And you certainly don't need a number line in either case, right? Example 2, two numbers, negative 10 and 6 are shown on a number line. What is the distance between the two numbers? Well, it's grade 4 math maybe or something, number lines. Isn't it 16? Right, from negative 10 to 6 is 16. Now, how many of you just got that just by looking at it? Okay. So the question now is, how can we write that distance? How could we have calculated that distance? Well, you could have said that this distance, that this total distance is equal to the absolute value of negative 10 plus the absolute value of 6. That would work, wouldn't it? Because the absolute value of negative 10 is how far away from 0 negative 10 is. The absolute value of 6 is how far away from 0, 6 is. So you add those two distances together. That would work. And by the way, just to show you that that's true, the absolute value of negative 10 is 10. We're not done with this question. The absolute value of 6 is 6, so it's 16. It checks out. Could we have done this? Could I have said, let's just subtract those two numbers. Let's take 6 minus negative 10. And before you answer yes or no, I mean the answer is yes, obviously. I hope you understand what we're doing here is if you want to know how far it is from point A to B, you can take where B is and subtract where A is, and you get that answer, right? So do you agree that this gives you 16? Could we subtract the other way? Well, we could if we do an absolute value. And we could have done absolute value here as well, even though it's not necessary. In either case, you're going to get the absolute value of 16 or the absolute value of negative 16, which is 16 as well. How many of you in your course of maybe junior high math, or maybe even this year or last year, you do some work on a calculator that involves subtraction, and you get an answer that's negative and you know it should be positive, and you realize I just subtracted the wrong way? If you understand the concept of absolute value, you don't need to worry about which way you subtract, if that's all you're doing. If there's other math involved, you do need to worry about that. Number 3, evaluate each expression. Well, this set of absolute value symbols is to be treated like a set of brackets in terms of your order of operations. So you do what's in brackets first. We do what's in the absolute value signs first. So this becomes the absolute value of negative 14, which is 14. I feel as though I should point out to you that what we did was we simplified what's inside first, then took the absolute value of it. Don't think that you can take the absolute value of negative 4 and the absolute value of 10 and do it that way. Because if this were, where'd that come from? I will make a different question here, A part 2. If we had the absolute value of negative 4 plus 10, that's the absolute value of 6, which is 6, right? Would you agree negative 4 plus 10 is 6, and the absolute value of 6 is 6? Okay, good. Would you agree that somebody who thinks this means you just change everything to positive would be wrong? Because if you did that, you'd get 14. And it's not 14, it's 6. So I guess maybe what I'm getting at is just because you see absolute value doesn't mean you just have permission to change everything that's negative to positive. It's not what it means. The absolute value of 3 minus 5 times 7 is the absolute value of 3 minus 35. 3 minus 35 is negative 32. The absolute value of negative 32 is 32. Five times the absolute value of negative 2 plus the absolute value of negative 3. Well, the absolute value of negative 2 is 2. The absolute value of negative 3 is 3. 5 times 2 is 10 plus 3, 13. There's nothing really complicated about this math-wise, not conceptually. It's all about understanding what that absolute value notation means. Well, we have to simplify what's in brackets here first, and just in preparation for the next unit, well, brackets, I call those brackets, and just give me that permission. In preparation for the next unit, let's remind ourselves how to add fractions. We need to determine a common denominator, and this is how I would like us to do it. I don't want us just putting in our calculator the numbers. Negative 5 is negative 5 over 1. We have a lowest common denominator here equal to 5. And that means that I can multiply the top and the bottom of this by 5. Getting negative 3, and then in the absolute value, negative 4/5 plus negative 5/5. Nope, negative 25/5. We can add those together now. That'll be negative 4 minus 25 all over 5. It's negative 4 plus negative 25 all over 5. I just wrote it as negative 4 minus 25, which gives us negative 3 times the absolute value of negative 29/5, which gives us negative 3 times 29/5. Can multiply across the top and across the bottom. Negative 87 over 5. Can you check my multiplication? I'm pretty sure that's right. It is? Okay, good. Hey, oh, wait a minute. Can we get a negative for an answer? I thought we were doing absolute value. We get a negative for an answer because the question had negative 3, which is a negative number, multiplied by this, which will be a positive number. We're going to get a negative. Just because you see absolute value doesn't mean that everything's positive. Determine the value of each of the following. Well, I'm using the opportunity with this example to illustrate the difference between this and this. What this means is negative 4 times negative 4 times negative 4. What this means is negative 1 times 4 times 4 times 4. And I will be the first to admit that if you confuse the two, it wouldn't matter here, because they're both going to end up being negative because of the odd exponent. But inside of the absolute value symbols, we get negative 64 minus 64. Negative 4 quantity cubed is negative 64 minus 4 cubed, which happens to be 64. So we get negative 128, I believe, in the absolute value symbols. So we get 128. Done. Again, I would like us to work with fractions. Now, just to make sure you understand what it is I'm doing in this step, I'm rewriting the question, but I'm also dropping the absolute value signs. So that absolute value of 3/4 is just 3/4. I don't need the absolute value signs. Minus 2. These large sets of brackets are not really needed, but minus 2 times 1/4. Where did the negative go on the quarter? Well, it's the absolute value of negative 1/4, which becomes just 1/4. This is 4 times negative 9 over 2. I have inside of that brackets the following. How I got the 9 over the 2 was I reduced this by a factor of 2 and this by a factor of 2. So multiplying across the top is negative 3 times 3, and across the bottom is just 2. 2 times 1/4 is 1/2, because 2 has a factor of 2 in it and 4 has a factor of 2 in it. I don't really believe that I should have to, nor should you have to write this out to understand why we get 1/2. Nevertheless, there it is. So now I have negative 36/2 minus 1/2, and I have a question for you. Why do you suppose I didn't reduce the 4 and the 2 down here? I could have, and I almost did. Any idea why I left it that way? Yeah. Exactly. I got common denominator. If I get rid of the 2, then I'm just going to have to find a common denominator anyway. So I get negative 37 over 2. These are certainly things you could do in your calculator. Speaking of which, let's do this in the calculator. Let's take just a little break right now. The fraction part of my brain is starting to leak. It's too full. So I am going to go 5 times 2 divided by 3 minus 8 times 5 divided by 6. I don't need brackets for that. Get that number, which is 10/3, unless I'm mistaken. But it's the absolute value of negative 10/3, so that gives us 10/3. Is that the final example before the word problem, or is there one more? One more. Okay. Okay, I guess I can show you something in a, I'm going to hold off on something. Let's calculate this first. Let's calculate 5 squared minus 8 squared. Well, that's negative 39. So what we have is negative 7 times the absolute value of negative 39 all squared, which is negative 7 times 39 all squared, which I want to say is negative 273 all squared. But can you help me out on that? The 7 times the 39, 273. So that's equal to 273 squared, whatever that is. We could work it out. $74,529. I'm going to go back to this one. Could we have entered this all in our calculator and hit equal to get 10/3, not negative 10/3, to get the answer? And the answer is yes. If you go to your math menu, and then you have sub-menus, I call them. You have the math main menu, you have numbers, you have complex, you have probability. If we scroll over to numbers, you see ABS. Okay? And depending on the calculator you have, and depending on the mode it's in, I'm willing to bet that hardly anybody's calculator is showing what I'm showing up here. Is anybody's calculator showing that? Wow, good. I like that. Do you have an 83? TI 83? Okay, so that's why yours is showing it. You have an 83? Do you have an 83? TI 83. Calculator, an 84. So yours is showing it for a different reason. We need to have a little discussion here, and it's not going to take long, and it's worthwhile. Put up your hand, please, if when you go 2 and you hit this button, you see that. Okay. Put up your hand if, let's do a new one. Let's do mode. Oh, we're good. I think we're good. No, we're not. Put up your hand if when you do that, that happens. Okay. Everybody whose hands are up right now, when you type and you get to the end of the screen, your stuff goes off the screen, doesn't it? I don't like that. I don't like that because I can't look back at what I've just typed. And if I've made a mistake, it's hard to find. Okay. I also don't like this because I will do stuff like, if I have to go 5 squared minus 3, I'll go 5 squared and then I'll go minus 3 and I'll do all this typing and I'll forget that I have to use the arrow to get out of there. You know what I'm talking about, right? So, did you know you can switch back and forth between modes? Or maybe you're just in a particular mode and you never knew. If you go mode on your calculator and you scroll up or down, you just have to scroll down far enough, I think. There's what's called Math Print and there's Classic, and I prefer Classic. Okay? But what that means is when I type something like 5 squared on mine, it appears like that. When many of you type it, it appears like that. Okay? It also means that when I go math number ABS, this is what I see. But many of you, when you go math number ABS, you actually see absolute value signs. Regardless, we could just enter the stuff into either of these. 5 times 2 over 3 minus 8 times 5 over 6. Hit enter. Do the same thing over there and hit enter, and it will do the whole absolute value for you. Okay, we have one more example that I want to go through. Number 5, in science, experimental error in a lab activity is given by this formula. And who was in my, I know I should know this, but lately time to me is just this thing that spans years sometimes in my head, and it's only been a few months. Put up your hand if you've taken Physics 20 with me this year. Right now I remember you guys. Okay, good. So in physics, we did not have these. And I'm about to explain why, but in chemistry, anybody taken chemistry where you have this formula? As your chem teacher explained what those lines mean? What do they say? What do they tell you, Ashira? So they say basically, let's just find out the number. If it's positive or negative, it doesn't matter. Let's just record the positive. Do they use the phrase absolute value?
Yeah. Well, in Chem 30 she did.
In Chem 30 she does. Okay, so you may be familiar with this already. In physics, I'd like to leave them out, and I'll talk about why in a second. So what you do to determine experimental error is you take the experimental result of an experiment, subtract what you should get, divide that difference by the theoretical value, what you should get, and multiply by 100. So in an experiment designed to determine the acceleration due to gravity here in Alberta, Sue gets 10.4 meters per second squared. Peter gets 9.3 meters per second squared. What they should be getting is 9.81, but here in math we just say 9.8. What's the percent error for each student? Well, for Sue, the percent error will be the absolute value of what Sue got minus what Sue should get over what Sue should get times 100. For Peter, the percent error will be equal to the absolute value of what he got minus what he should get over what he should get times 100. So let's calculate Sue's, and I'm going to do it in pieces. 10.4 minus 9.8. I don't want to use that calculator. I don't even want to do the absolute value. Okay, I just want to do the inside. 10.4 minus 9.8, hit equals, unless you put that in brackets, divided by 9.8. And I get that number. And that's the absolute value of that times 100. Over here, 9.3 minus 9.8. Divide that by 9.8. I get this number, 0.051, and it's negative. Times 100. So if you take the absolute value of 0.061, you get 0.061 times 100 is 6.1%. If I take the absolute value of negative 0.051 and times 100, I get 5.1. And we're done with the math lesson. But listen, how would these numbers be different if the absolute value signs weren't in the equation? would we still get 6.1 if the absolute value signs weren't there? Yes. What would we get for Peters? Negative, wouldn't we? Why, in physics, do we not include them? This is beyond the course, but we don't include them in physics because physics is more precise than chemistry. What does that negative tell us about Peters' result? It's 5.1% below what it should be. I don't know why in chemistry they don't worry about that. But it seems like in physics and I was kind of joking, saying physics is more precise. I just say that because I'm not a chemistry teacher. If I was teaching chemistry, I'd say chem is more precise. And those physicists are doing stuff they don't need to. This is saying it's 5.1% too low. This is saying 6.1% too high. But everything below that red line has nothing to do with this class. I'm just talking physics here. Some questions to practice with absolute value. It's a really basic idea. Don't forget that assignment number 4 is due tomorrow. Hopefully you haven't neglected it up to this point in time. I can see by the grins on your faces that some of you may have been neglecting it. You got about a little under 10 minutes here to work on that assignment if you like, or work on this practice stuff.